ROM, read only memory. Read only memory. Now, the RAM is not practical for one output. Like if you only have one output like this, that's not really good. I'll tell you where the RAM comes in handy. Something like 7-segment LED driver. What is that? This is what your 7-segment LED driver looks like. A, B, C, D, E, F, and G. This is supposed to present 0, 1, 2, 3, 4, 5, 6, 7 when you write on your calculator, right? One digit. So a 0, which one you want to light for a 0? A 0 will be like this. The 1, you got to decide, is it the first or the second row? Which one you want it to be? You're the designer. For the 1, do you want to light these two or these two?
Second.
Which one?
Second.
Second one? So we'll go like this. For the 2, three, 4, 5, 6. Do you want to put a loop on it or just straight? You have an option because some people make the 6 like this. Some people I want to do it like this. Okay, 7, 8, 9, the single digit, so you can have a 10. 0 through 9, how many choices? 10. That means you need at least 4 inputs to give you 2 to the 4, which is 16. 3 will not be enough. 2 to the 3rd will be what, 8? That's not enough. So I need 4 inputs. My inputs are A, B, C, and D. When you type A, B, C, D, bless you, let's look at, oh, I can't use A, B. I'm using A, B, C, D here, right? So let's use what? W, X, Y, and Z. W, X, Y, Z. My output this, I want to tell them if I put 0, 0, 0, which one of these I want it to be on. So I want G off, the rest I'm on, right? So here's my output. A, B, C, D, E, F, and G.
Where's F? Yeah, is that on the top?
A, B, C, D, E, F, G. Yep, F is the top. Yep. So when you press a 0, so here we go. 0, 0, 0, 0. Which one you want to be on? All of them except what? G. G is 0. The rest all ones. When you put 0, 0, 0, 1, we said the right side, A and B, right? And the rest are off. When you type in 0, 0, 1, 0, 0, 0, 1, 0, that's a 2, right? 2, that means E and B are off. B is 0. And we said, which one, the other one, 0? E. When you do 3 there, all of them are on except D and E. 4, I'll go to the next line, 0, 1. No reason why I jumped the line, just looks like everything's squished there. I'm off sync there, it looks like I'm not lining up right. So I'm trying to line up there. 0, 1, 0, 0. That's the 4. C, D, and F off. C, D, F. The rest of them are 1s. How can you be off? Oh, yeah, I'm off. Looks like it, huh? Still. So let me erase the one above it, because I was pushing down. Maybe that'll put me back on track. I'm using like a square boxes. Should leave me in track, but I keep getting out of the boxes there. 0, 1, 0, 1, 5. 5, A and D off. A and D. 6. All of them on except A. 7. F, A, and B. 8. All of them on, right? Every one of them. And 9. 9 is what? All but D. And somehow magically, what happens if I end up getting 10? I'm leaving a space so I can come back here. 8. I really shouldn't have 10 or what? Or 11. Or 12. Or 13. Or 14. Or 15. None of these should be there. You can say don't care, right? Or you can have the machine print. What's that mean? Error. You're the designer. If you encounter that case, it should not happen. When you press the button on the calculator, you press the 0, the 1, all the way through what? 9. There is no 10, 11, 12, 13, 14. If the machine is acting funny, ends up being somewhere here, you can tell them to make it error. An error, again, you want A and B to be off, and the rest of them on. Now, if you want to use multiplexers for this, how many multiplexers are you going to need? 1 for each letter. I need 1 for A, 1 for B, 1 for C, 1 for D, 1 for E, F, G. This is known as 7-segment LED. Why they call it 7 segments? It has 7 functions, A, B, C, D, E, F, G. You will need 7 muxes, 7 16 by 1 mux. The first one, it's going to be for A. You're going to attach the 1s and 0s to it, VCC or ground. The second one, the third one, the fourth multiplexer, the fifth multiplexer, the sixth multiplexers, the 7. Or you can get a ROM. If you decide to get a ROM, you send this to the factory. Say, I want a chip that will work like this. This is what the inside of the chip should look like. This chip will be 16. They don't come by 7. I need 7. It will be 16 by 8. But the first one I'm not using. So you send this to them and say, I like my chip when I get it back, inside that to have these. The first column is empty. I'm not using it. So there's an empty column here. I have 8 outputs. So that's known as 16 by 8 RAM. That's a small chip. You might not get 16 by 8. It might be 64 by 8. Well, if it's 64 by 8, you only use the top 16 and leave the rest empty. But the way the chip actually has a couple of things on it. It has an address location here. Because it has 16, that means it has 4 select signals. W, X, Y, Z. And this is 16 by 8 is going to have an 8 slot here for your output. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9. Delete 1. So when I type in, for example, here, if I go 0, 1, 0, 1, that means what? 5. Make sure address 5, this is address 0. This is the 0 location. This is the 1. This is the 2. This is the 3, the 4, the 5, the 6, the 7, the 8, the 9, so forth. Make sure whatever in row 5, 0, 1, 0, 1, which is 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, show up right there. So that'll be what? 0, 1, 1, 0, 1, 1, 1. I'm not using that one. So this will be attached to A. This will be attached to B. This is your C. This is your D. This is your E. This is your F. And this is your G. Notice I'm not using the first one, so I could care less what they put in it. If I type in 1, 0, 0, 0, that's 8. Make sure whatever row 8 here, which is actually the 9th value because the first one is 0. Make sure these numbers are here and you get your output. So they just put the 1s and 0s inside that based on this address. Well, they don't want drawing something like this. They don't like the way we draw them, so they came up with a different way of doing it. And a few minutes we have. Let's do this. God help me. I asked for this one. They said, well, I should just scan that one. But I'll finish it. I'll stop whining and I'll finish it. So I have W, X, Y, and Z. I won't draw all the lines going through it, but I'll just give you an idea what they wanted to draw now. Because if I do that, my paper has to go twice the size of that, maybe. W, X, Y, and Z. And I also want to do a NOT gate for each one. There we go, a NOT gate for each one. So you have to draw them like this. They don't like the box one we drawn before. That looks nice, neat. I'm going to use the red mark because this pen is like, I'm going to have to go twice over it to make it work. What's attached to the first one? It's an AND gate. Here's the first one. I can't really fit them all in here. So this is an AND, not an OR, an AND gate. And there's another AND gate. And there's another AND gate. There's 16 of them. That's how they want you to graph them. I'm not going to do them all, but you get the idea. And you want the first one to be on when it's 0, 0, 0. So let's attach all the zeros to it. That's 1, A0, B0, C0, and what? D0. So when all 0, 0, 0, this guy is on. The next one's going to be on when it's what? 0, 0, 1, 0, 0, 0, 1. Good luck, you'll go blind. The next one's going to be what? So this is 0, 0, 0, 0. This will be what? 0, 0, 0, 1. The next one is what? 0, 0, 1, 0. So A is 0, B is 0, C is 1. A is 0, B is what? Or W, the other one is 0. This is 1. Where's the 1? Down here. And the last one is 0. Is that a 1? Yes. The last one is 0. You got the idea, everyone? Do I have to do them all? So that's how we attach to them. Then in the bottom, you got to do an OR gate. This is for A. This is for B. This is for C. What was the last one? G. You want A to be on when what? You want A to be on when it's, what was it? Where's A? At 0. At 1, at 2, 3, 4, 7, 8, 9. So you attach this to it. You can see where we're going with this. It looks like a nightmare. Zero, 1, 2, 3. And you keep going. Well, we realize that's too many lines. Nobody's going to be able to trace that. That's crazy. You do the same thing for B, C, and G. So instead of drawing all these lines, now we draw one line. And we put dots where you want to connect them. Instead of having this, this, and that, if I want to include all of these, we do one line. We do that. The same thing, instead of drawing 4 lines here, like for the next one, instead of doing 4 lines here, we do 1 line. And this is supposed to be what's attached to it. This is 0, 0, 1, 1, right? So you draw 1 line. This is the 0, 0, 1, 1. You go 0, 0, 1, and 1. Now everyone get the idea. That's really 4 lines, but that's how we draw them. Less work. This one, for example, 1, 1, 1, 1. That's the last one. We draw 1 line going to it. Because to draw them all is hectic. To do them all, you go, here's 1, 1, 1, and 1. That's what that means. And instead of drawing all these lines for B, we do one line this way. And we attach when B is 1. You want B to be 1. Here's B at 0, 1, and 3. 0, 1, not 2, 3. And you make it one line. And you do the same thing for C and D. It makes it a little bit easier to see and track. So it'll be less wires going through it. Because just realize that's too much. First we're doing this way, then go, oh no. People start to go, no, I can't follow what you did there. Too many lines, where is this going to? Nobody can read them. So if you look again, I'm showing you here in the book. This is how we used to do it. See all the lines? Then we went from that to a single line. And that looks cleaner. Notice this is A naught, B naught attached to it. Instead of going, here's A naught, this is A, B, and C going to it. This is A naught, B naught, C naught going to it. And you do one line this way. It says, okay, this one will be high when you have A bar, B bar. When you have this, and that's it. So we went to that look because the other one is too much. Too ugly to draw them like this. I don't care how good we are. Even if you have perfect eyes, you're trying to read these lines, good luck reading them. So when you ship it to the factory, you ship them that one, and they'll put without listing this, like the gates. They don't care about that. And there's no simplifying. You just do all 16 combinations, and you put your output. And you get your chip burned that way. Make sense? So that's multiplexers and decoders.